Hello. Yeah. Uh, Thank you, Commander Narayanan, for that extremely, insightful presentation. I think so far we only knew that if there is something precious under 10 grams or 1 gram, it could be like a jewelry or gold-like thing. But it is the human passion which could convert any substance into something as valuable as the gold. Uh, Our next speaker this evening is an aviation safety expert with the International Civil Aviation Organization, that is ICAO, Montreal, Canada. During his service at Indian Air Force, he flew Canberra bomber reconnaissance aircraft and took active part in India-Pakistan War of 1965 as well as 1971. He was assistant director of operations at the air headquarters at retirement. Later, he worked as a senior instructor on Boeing 737 and Airbus 320 aircrafts at the Central Training Establishment of Air India. Further to that, he served as an expert to several aviation authorities across the globe in countries including New Zealand, Australia, Canada, France, Germany, Malaysia, and participated in restructuring of national aviation authorities and led the teams conducting safety audits for fleets as well as airports. Coming to his academic achievements, he holds an MBA from the Victoria University of Wellington, New Zealand, and was awarded the highest award of achievement by the Dale Carnegie Association, USA. He was conferred with its fellowship by the Royal Aeronautical Society of Great Britain. He is a member of the advisory panel of the ICAO on the review and revision of the ICAO annexes and the aircraft accident investigations since 2001. He has led the investigation teams of several major aircraft accidents, and the investigation reports led to the improved training and operation procedures across the aviation industry. To summarize, his career significantly improved the safety of civil aviation across the globe, and every air passenger should be thankful to him for that. He has shared his vast experience by writing articles and books on civil aviation safety and security and defense. He is chairman of the Sanskrit Vidya Mandir educational organization in Pune. Please join me to welcome our next speaker of the day, Wing Commander Vinayak Davray, for his signature topic, Aviation Safety Investigations. Wing Commander Davray, for the speaking.
First of all, I must thank the organizers for giving me this opportunity to speak with you. So, chief guests, the other speakers, Sapre family, Kare family, and the august audience here. Huh? Can everybody hear at the end there? Okay. Now, after hearing two very informative talks, I'm going to take you into a different field, that is the safety field. And here, what we as a passenger look at the aircraft and fly, and only when there is an accident or any such occurrence, we get concerned how these things are happening and why these things are happening. And sometimes the investigators or the investigation reports come to us, in which we come to know that some of the things happen because of X, Y, Z. but we do not know the details of that. Therefore, this is an endeavor here that I'm going to give you overview the how the safety investigations are carried out, particularly in aviation. Next, please. In the outline, we'll cover this topic under the heading of enhancing the aviation safety. There is something known as Safety Oversight Organization. In that, we have state regulatory oversight. That is, governmental regulators who are regulating the aviation, their oversight on the safety aspects of the aviation in that particular country. The next comes airlines' own oversight organization, what airlines are doing to maintain the safety of their passengers. Next, what are the objectives of the investigations as such when you carry out the safety investigation? Then what are the investigators and their properties? And which are the guiding documents which are telling the experts how to do the investigations? The flight recorders, you must have heard lot many things about the flight recorders. We'll see them in details. ATCC, that is Air Traffic Control Center, they also have some recorders. We'll talk about them as well. Then, when an accident occurs, initial 48 hours are very important, not only from the rescue and the recovery of the aircraft, but also from the investigation. What you get in first 48 hours is extremely valuable for investigation and finding out what exactly has gone wrong and what shouldn't have gone wrong. Then phases of investigation. There is a theory about investigation, something known as Swiss cheese model. We'll have a look at that. Then we'll actually see some of the aspects of one Gulf Air Airbus A320 accident. I myself was the chief investigator of that accident. Then responsible factors for any accident. Does it appear to be too long a subject? We'll make it interesting. It's not too long. Coming back to the state regulatory oversight, there are two distinct aspects. One is airworthiness oversight and other is flight operations oversight. Now you'll wonder what is this airworthiness? We may not have heard this word at all. Airworthiness is actually the engineering aspects of the aeroplane, or design and engineering aspects of the aeroplane. And there are certain norms laid down by various authorities, and they have come about over a period of time. Since the advent of the aviation, how the various evaluations have taken place, similarly, all these norms have come to stay. 50 years back, you heard most of the air accidents took place because of the technical faults. Nowadays, when an accident occurs, you rarely hear about a technical fault because the system has so evolved that the technical faults have become almost negligible. This evolution has occurred because of the efforts taken by experts in the field, and that is how this airworthiness oversight has become nearly a foolproof process. To give you an example, how stringent checking and testing measures are done. You may have heard about aircraft Boeing 767. There are various numbers, but this aircraft has a specific history. That is, up to this aircraft was allowed to fly across Atlantic Ocean on 2 engines. The normal practice crossing Atlantic was only on 4 engines or 3 engines. 767 was the first aircraft permitted to fly across Atlantic on 2 engines. And this aircraft had to do, a prototype aircraft had to demonstrate 10,000 hours of flying across Atlantic before it was certified. So see how stringent measures are taken for doing testing for safety purposes. Now next is flight operations oversight. Now, one aspect is the aircraft and its design and its engineering and maintenance. Other aspect is actually flying this airplane with passengers across the globe. So when you are doing this flight operations, similar oversight is done, similar norms are established over last 100 years, and try to bring the safety aspects as maximum as possible. And what we call it accident rate, so many accidents per 10 million hours of flight. And this accident rate is being reduced over a period of time. That is why nowadays we don't hear aircraft accident taking place every few months. Then, about 50 years back, almost every few weeks, there was one accident happening about the aircraft. Then airlines' own oversight in both these aspects, that is airworthiness and flight operations, they do something known as quality assurance. The quality assurance associated with the various design and manufacturing, they would know how the qualitative assurance is done. There are various norms established again in what needs to be done to maintain safety, like on the shop floor, similarly in the aircraft operations as well as airworthiness. This was a news item about a week back, and I'll read out the news item to you. United States Federal Aviation Administration, known as FAA, team conducted a safety audit of Directorate General of Civil Aviation, India, for 7 days. This audit follows a 5-member team audit by FAA in October 2021 that have investigated safety guidelines, including licensing of personnel, flight operations, and airworthiness during their audit. This news came out on 28th of April. News further follows. This is not the first time FAA had audited India's DGCA. The United States agency had downgraded India to Category 2 in safety oversight capability in January 2014 over 2 key concerns: lack of training of officials and absence of full-time flight operations inspectors on DGCA's role. A Category 2 status meant Indian Airlines will have to go through stringent scrutiny for being able to operate flights to the United States. This news item I felt was important, and I added the slide here, because this type of safety audit is a regular phenomenon, and that is what keeps us safe in the skies. These safety audits happen all over the world. When they were instituted internationally in 1995, I was associated with that from the start. So initially, a training was given to various experts how to conduct safety audits of the airlines, not only for flight operations, but for the airworthiness of the aircraft. And there are over 400 parameters which are checked by this type of audit team. And then the audit team will give a report how safe that particular country's aviation is. and they will go and check each airline and the regulators. So this is what the system is in place. Now the next step, that is the each other's aviation authorities, like in this case we read about flight, the FAA of the United States and Indian authority, that is Director General of Civil Aviation. Now they inspect each other's safety audits, or they conduct each other's safety audit and satisfy themselves that the safety norms in the other country are satisfactory so that they can go and operate there. Now this type of things go on. They started in 1995 and go on continuously. So experts are to be trained to do this type of audits. The audits are not only done, but also advice to the countries and the airlines that what needs to be fixed. We saw a couple of examples here as well, that what the FAA experts had told Indian carriers and Indian regulator, what they need to be fixed. I have only given a couple of examples, but it's a very intricate task, and this is what regularly happens, keeping the aircraft and passengers safe in the air. Now, the objective of any safety investigation, or the sole purpose of an investigation of an accident or an incident, shall be prevention of accidents and incidents. It is not the purpose of this activity to apportion blame or liability. This is the what say Baba Vakyam Pramanam in the aviation or the aviation safety. Whenever an accident occurs, in the earlier times, people used to ask, oh, who went wrong? Or what went wrong? Find some scapegoat and fix it. That type of mindset is gone long back. And here the purpose of any investigation is to prevention of accidents. And out of every investigations, normally you find some of the training modules come out, and those people who are associated with that, training is given to them. They may be airworthiness technicians, engineers, or maybe pilots, flight engineers, or whosoever is connected with that aviation, and wherever we find there could be something going wrong, the training is imparted so that that type of errors can be avoided. Yes. Now, who are the investigators? Normally, you have from the basic streams of the flight crew, which are pilots, navigators, or flight engineers, immaterial whether they are from the armed forces or from the civil. Then airworthiness and maintenance engineers of the aircraft, and air traffic controllers who are normally associated with the flight of the aeroplane. So the normal stream comes out of that. However, there is a recent, I shouldn't say really recent, it's about 30 years back the practice started. The generic investigators are also trained, particularly at National Transportation Safety Board of the United States and BAE, that is actually an investigation organization of France. These two countries have started training the investigators right from university graduates. Then, what do we look for the qualities in an investigator? First of all, the investigator must be a keen observer. He should be able to pick up what is going wrong. He has to have that keen sense of observation. Then he must be courageous and fearless. Why courageous and fearless? Because an investigator may be questioning even a chief executive of an airline or the director general of the civil aviation. So he has to be courageous to do his job and also fearless, expressing his opinion. Then only he can do an impartial investigation. And he must have a quality of perseverance. Any piece of evidence he finds, he must go to the end to find whether that piece of evidence is responsible for any mishap. Next, please. Now, there are various guiding documents. I'm just going to list them here. So, basically, I want to make a point here that how extensive guidance material is available. The Bible of Investigation is International Civil Aviation Organization's Annex 13. Its heading is Aircraft Accident and Incident Investigation. Then there are various other documents. There are documents. Doc 9756 has 4 volumes, Manual of Aircraft Accident and Incident Investigations. Each volume is over 700 pages. And these volumes go on, they are dynamic documents. That means they go on getting modified and amended from time to time, virtually every year. Next, please. Then there is another document on Human Factors Training Manual. This deals extensively with the human factors involved in an accident. Then next is Manual of Aviation Medicine. Aviation medicine has come out to be a very vast branch of medicine. And there are a number of aspects in the aviation medicine which are associated with accidents. That's why it's a specialist subject, and these documents are given as a guidelines documents. Then training guidelines for the accident investigators. This is the Bible of investigators. An investigation of human factors in aircraft accident. So these are the various documents available. So you can imagine now how the training of an investigator, how extensive it would be, apart from the basic experience he has. This is the Annex 13. It's not too long. It's something like little over 100 pages. Next, please. Now we come to the interesting factor of the flight recorders. Flight recorder is an electronic recording device placed in an aircraft for the purpose of facilitating the investigation of aviation accident and incidents. The device may often be referred to as a black box, an outdated name which has become a misnomer. Fitted with electronic locator transmitter known as ELT. Every flight recorder is fitted with this ELT. The battery life is about 30 days. So that if the aircraft goes underwater or has an accident in a very remote place, still such recorders can survive, and we can track them using their ELTs. The ELT transmits a particular signal regularly, and that helps the search aircraft to find that record. Next. Now, although we call them black boxes, they're orange in color. We'll see them shortly. And there are 2 of them. One is a flight data recorder, and it's a digital record of all aircraft parameters for the last 25 hours of aircraft flight time. These parameters are depending upon the manufacturing of this flight data recorder. It's as many as 400 parameters of the aircraft are recorded, and it's a digital record, so you can read them once the recorder is found. Then next is cockpit voice recorder. It actually records only 30 minutes of the conversation in the cockpit. It has got as many as 5 microphones kept in the cockpit of an aeroplane. Normally there are 2 pilots, so each one speaker or the microphone will be connected with this cockpit voice recorder. Plus, there are 2 microphones kept in the cockpit itself. So any other noise coming in the cockpit, because for the investigation it's very important to know what noise or any other voice is happening there. And the 5th is if there is another crew member like a flight engineer or a navigator, then that mic is used for him. So normally there are about 4 to 5 microphones kept in the cockpit, and their running record of 30 minutes is kept. And when the accident occurs, this particular cockpit voice recorder stops. So you always have last 30 minutes of flight's cockpit voice recorded in the CVR. Next. Now this is the flight recorder actual. See the color, and why orange? Because it is very easy to detect from the air, even if over 10 to 15 miles, you can locate this type of object if it has orange color. Next. This is another type of flight recorder. And normally they are kept at a remote place in the aeroplane, the tail end or one of the wingtips. And they are hermetically sealed. Some of you may understand the meaning of hermetically in the sense, even if many 100 pounds of pressure is applied to the body of this, it will not break. That is why it is called hermetically sealed. So it is survivability is ensured of these flight recorders, and the equipment inside normally remains intact in spite of many accidents. So the flight recorders actually started working in the aircraft something like 60 years back. Before that, you can imagine the task of an investigator, how hard it could have been. Because they had no records, you have to go by whatever you get available, the parts of the aeroplanes, or if any survivors are there, their testimony, etc. So flight recorders have actually helped a lot, and we'll see actually how the flight recorders help comes. Next. Are there. Voice recorders at air traffic control centers are also there. There's something similar to that of cockpit voice recorder in the aeroplane. So air traffic control centers have two areas where this type of recordings are there. One is a control tower, which controls the traffic, air traffic within the aerodrome and on the circuit of the aerodrome up to about 1,500 feet height. And there is a area surveillance control or air traffic control center, as they call it, that has traffic aloft. That means above 1,500 feet, traffic is all controlled by the area center, and that is normally equipped with a radar. So there are two types of recorders are there. One is the voice recorder and other is the data recorder. So both are scrutinized, and they, like that of flight data recorders, these recorders are also useful in the accident investigation. And most valuable evidence, I said, comes in first 48 hours, because as they say that after 48 hours, the trail goes cold. That means whatever information you receive, its reliability goes reducing. Therefore, the accident what we are going to see that just after this. Okay, next one, please. Before that, let us see the phases. First is gathering of factual information. Then is analysis of that information, the conclusion and safety recommendations. What we normally see as a level, only last part, that is safety recommendations. But that is all built up on the first three phases, and which are equally important. Next. And reports, there are two types of reports. One is preliminary report. Once the factual information is collected, then a preliminary report is generally given, in which the conclusions and analysis is not given, so the public knows what has happened. So normally such factual report or the preliminary report is given as soon as possible. Generally, general guidelines, within about a week or 10 days, the preliminary report should come out. then final report takes many a times number of years because not much analysis had to be done and the conclusions have to be arrived and then safety recommendations are given. But when safety recommendations are required urgently, then all these norms are kept aside and they are urgently followed. I will give you an example here. In 2002, there was a mid-air collision over Germany. There is a Lake Constance in Germany, which is the largest lake in Europe. So accident occurred over that lake. There were two aircraft in that. One was a cargo aircraft, Boeing 757, and other was passenger aircraft, 154, which is a Russian aircraft, which was carrying 72 passengers. Cargo aircraft had only 2 pilots in there and a lot of cargo. So 74 persons were involved in that accident. Mid-air collision occurred over the Lake Constance and all 74 souls perished in that accident. Now, why I'm giving you the example of this accident? Basically because the parameters what we got to see in that are interesting part. It has passenger aircraft was carrying mostly children and their parents to Barcelona from Russian airfield for taking parts in games. Why the accident occurred? Because 2 aircraft were following 2 different norms. International airspace had a particular rule, that is, when any aircraft flying in international airspace, there is an equipment on board aircraft, each passenger aircraft, known as TCAS. In short, for us to understand, is any aircraft coming close to it, the warning signal 2 ways, audio and visual both will come to the pilot. And audio signal will tell him the other aircraft is below him. The audio signal will automatically, without human intervention, tell him that you climb. Similarly, the other aircraft which is below that aircraft will give an audio signal to descend. In other words, there will be separation between 2 aircraft and the separation would be increased. So that was a norm. Now, however the conflict came, one aircraft was Russia. Russia in their own airspace did not have this type of equipment on board aircraft. Therefore, they had the instructions that within the Russian airspace, if you're flying, the air traffic control instructions take priority over the TCAS signal. TCAS means that particular collision avoidance equipment. Because they didn't have the TCAS equipment. Whereas international airspace had a norm that each aircraft must have a TCAS. And the norm was, if there is a conflict between air traffic control instructions and TCAS signal, the priority goes to TCAS signal. See the conflicting instructions. Now, the Russian pilots who were flying in that Tupolev aircraft were tuned to that Russian way of working, giving preference to the air traffic control instructions. What actually happened? 2 aircraft came very close, they were going at a right angle. They came close up to a certain distance, about 5 miles when they come. I'm talking about nautical miles, which is larger than statute mile. So when they come within each other, 5 miles in a very short time at the speeds of the aircraft. Each aircraft generally flies at about 600 miles per hour. Now, if two aircraft are going at right angles, you can work out the relative speed, which will be at least 1.5 times. If they are opposite, then the speed will be double. So, you can imagine at about 900 miles per hour aircraft they are closing in. So work out the time, how much time it will take to cover 5 miles. So that's a very short time. And you have very limited time to make decision. So first time the signal came to the Russian aircraft and they were told by ATC to descend. Whereas signal came from TCAS. Now the pilots were in confusion. What to do? There was a conflict between pilot and the co-pilot. Co-pilot said, no, we are in international space, so we have to do as per TCAS. And the captain said, no, as per our manual, we have to follow the ATC instructions. Before they could make a decision, the conflict occurred. Collision occurred. And the record FDR and CDR show that for 9 seconds, they had the warning by TCAS. Both aircraft, that is Russian aircraft as well as the Boeing 757 cargo aircraft. The signal was given by TCAS every second for 9 times. So they virtually had 9 seconds to make a decision. And in that, the collision occurred because Russian airspace had different instructions and international airspace had different instructions. Now, we as investigators felt this is an urgent matter. This recommendation must go immediately that both the airspaces must have same instructions which to follow, and we recommended TCAS must be followed because TCAS has no human intervention. It's all radar based and it is automatically generated signal given to both the aircraft, and this is absolutely 100%. Still, our recommendation by reaching and changing the rules, it took 3 months for us. That is the urgency. Let us go to the next one. Major factors in the air crashes. Now, this is what everyone worries about. Which are the factors responsible? Technical factors, airworthiness, safety assurance. We'll bring out the technical factors. And as I mentioned that this particular aspect has taken leaps and bounds so well that technical faults have become almost negligible. Coming back to human factors improvement is still lagging behind technical aspects because there are various other aspects in that. So in that, flight operations, air traffic control and others personnel who are associated, and safety assurance in each of the aspects is being done regularly. And next one comes systemic factors. Some of you may not have heard this. What are the systemic factors? There is a system, that is a regulator is there. The airline has got its own system. Now the systemic factors may be responsible for other human factors. Next one. Let us see that Swiss cheese model. This is the theory put up by Professor James Reason. That is why it's named after him. And this theory first came out in 1990. What he gives here a model. Yes, you see the 4 cheese slices. And he's calling them, each cheese slice has generally holes. When cheese is made, unlike our paneer, cheese forms holes in it automatically. And these holes, one size holes, may not be similar to others. They would be different. So if they are placed one after another, and if all the holes align, then only accident. That means there is no single factor responsible for the accident, and if all the holes or drawbacks get aligned, then accident can occur. So there are many factors responsible for accident. This is what the theory he put forward. And next one, please. Anyway, this is same thing. Next, go ahead. What James Reason recommended, that rather than cheese, let us introduce some shields there by which we can stop that type of errors or that type of failures, whether in the humans or technical or system, so that those rays do not follow. And that is what the theory, what he further says, that those errors are studied. Humans are bound to make errors. Humans don't make errors willingly. Therefore, if they are trained not to make such errors, they will not make errors. That is the theory he put forward, and that is on the similar theory. The training modules, what I was talking about, are based. A particular error is analyzed, and a training is given to those personnel, maybe air traffic control, maybe pilots, maybe engineers, so that that type of error they will not commit in future. Next, please. Next. This is a Boeing, Airbus 320 aircraft. Actually met with an accident on 23rd of August, year 2000. And this is the actual photograph of that aircraft which met with an accident, taken about a year back. And we'll study a few aspects of this aircraft. Am I going too long on my time? Okay, if at any stage it becomes boring, just stop me, okay? Next one. Now, after the accident, what happened? Let me tell you in the nutshell. The flight took off from Cairo in Egypt at about 4 o'clock local time in the evening. And it had about little over 3.5 hours flight time to a place known as Bahrain in the Middle East. And it had 143 passengers on it. Passengers and crew. 2 pilots, 4 cabin attendants, and 136 passengers. The aircraft came to land at Bahrain, but didn't make it, went into the sea. And all 143 souls died. So this is a Coast Guard boat recovering the parts of the aeroplane from the sea. Fortunately, the sea around where the accident occurred was shallow, not very deep. So recovery was not that difficult. Next one. This is another part taken out from the sea. This is the door taken out of sea, aircraft door. So, see what has happened to that aeroplane after impact on sea and thereafter hitting the seabed. Aircraft was shattered into pieces. So this is why I wanted to show you these pictures. So, but the recovery team, mainly consisting of Bahraini and United States Coast Guard, because United States, one fleet known as Fifth Fleet was based in Bahrain. So they provided the Coast Guard assistance. Bahrain itself had their own Coast Guards. So they did the recovery. And in fact, I was the chief investigator for this accident, and my team of 25 people, first 48 hours were with the recovery team. Next one, please. Okay. Without going into the traumatic aspects of the recovery, let us go into the technical aspects, how this accident has occurred and why it Shantanu, do I have the pointer? No, okay. I want to show it to See that? Any other mic available?
Yeah. Hello.
I'm going to show you the trajectory of the aeroplane. First of all, this is the northern part of the Bahrain Island. And this is the Bahrain runway. Direction of the runway is 1230, that is 120 degrees to the magnetic north. And that is why it is called runway 12, going this direction, or 30 going to this direction. And this is the path of the aeroplane, center line, extended center line of the runway. And aeroplane came from this. The trajectory is like this. Normally, landing or the approach path starts from about 5 miles. And when the aircraft is within 5 miles, it's called it's on approach, and less than 3 miles, it is called it is on final. So there are particular norms that how the aircraft should be flown on the final approach or the approach and final stages of the flight. So the green path showed here is the flight of actual aircraft little close to the center line. It is not always possible to fly exactly on the center line, so little bit variation is allowed. Whereas the black line is the extended center line. And actual path of the aeroplane goes like this. You follow my pointer, like this, here, and here, and here aircraft. Now, why did the aeroplane did this type of pattern? So we must understand that what happened is, aircraft when initially came on the final approach, it was two things. It was a bit too high. I don't think you can read here, but I can read it for you. Then it shows its speed was 215 knots and its height was 1,111 feet. Now, where did this information come from? It came from flight data record. And what conversation took place is also superimposed on this diagram. So this diagram was prepared with the help of flight data recorder as well as cockpit voice recorder. So initially we saw these two recorders. The importance of those recorders is that we can virtually plot the position of the aircraft every second. Now, perhaps you can see some of the dots here. I don't know, at the back you may not be able to see. Those dots are 4 seconds apart from each other. So how intricately the aircraft path is plotted, it is possible to do it if you have the flight data recorder's data deciphered as well as cockpit voice recorder's data also superimposed on that. So within virtually 3 days, this entire path was prepared and we knew what exactly happened. Before that, when I said that earlier the recovery was done, virtually 90% of the aircraft was recovered within 48 hours. And the aircraft part, each part was laid down in a hangar. Where they will be on the actual aircraft. Okay. So here, speed was 215 knots and height was 1,111 feet. Whereas the aircraft should have been about 65 knots less, that is 150 knots. So aircraft was flying 65 nautical miles per hour, speed higher than what it should be. Similarly, height there should have been about 700 feet, whereas actually it was 1,111 feet. That means about little more than 400 feet high. So aircraft was not properly placed for its landing. So pilot should have decided at that to go around. That means this is not a proper landing. He should have had to make another approach and come for landing. That procedure is called go around. Now, the pilot does not do that. The co-pilot does not remind him to do that. The co-pilot does not tell him that you are higher on speed. Because cockpit voice recorder tells us. It's not a rocket science. Cockpit voice recorder records every conversation in the cockpit, every small noise in the cockpit. Okay, so please note these two things and let us proceed. Now, pilot somehow realized somewhere here that he is not properly placed for landing, so he tells co-pilot to take permission for doing 360-degree turn to the left and come for the landing. This is what the 360-degree turn, what we see here. This is not a normal practice. Normal practice to go around is climb straight ahead to 1,500 feet, do 180-degree left turn, thereafter fly straight parallel to the runway for minimum 1 minute, then do another turn, 180 degrees, and you are back onto that path. That is the standard go-around procedure. And pilot, without following that, he requested for 360-degree turn, air traffic control approved it. So he conducted this 360-degree turn. Now see what is he doing at the time. First of all, while coming for landing, he was putting the aircraft in landing configuration. That is, putting his undercarriage or the landing gear down, putting his flaps down in stages. There are generally 3 stages for putting flaps down. So in this approach path he has done. Now he is doing 360 degrees. So what he has to do? He has to take the landing gear up. He has to take the flaps up in stages because each one is connected with its speed. So at a certain speed, he will put the flaps one stage up. Little more speed, put the flaps in another stage, and so on. So he was doing all these activities at the same time doing a 360-degree turn. So activities were too many. And when these activities are too many, what has actually happened? After doing the turn, he doesn't face the runway. He's facing this way. Almost 90-degree aircraft nose is away from the runway. So this is what actually happened and seen with the help of flight data record. Okay. So that time he realizes that landing is not possible even after 360. So he has to go around to another proper circuit, what I explained earlier, and come back for landing. So he asks permission for another go around. Air traffic controls clears, and he starts going around like this on this path. Now what happens? Interesting part happens like this, that he has to climb where 1500 feet, that is safe. To climb to 1500 feet, he uses something known as takeoff go around power, which is called toga power, take off go around, TOGA, which is almost maximum power. That means he has got the maximum thrust on it, and aeroplane is climbing. Now, while such things are happening, and already he has done too many activities before, he is doing another similar activities, putting his flaps up in the air. Now, by the time he climbs to about 1,000 feet, now put on your thinking cap of science. If you are in a car and you are accelerating, what do you feel on your body? You are thrown back. Now, in the aeroplane, if you are accelerating and climbing, both the things, what do you feel about the aeroplane? You feel the same thing. Your body is thrown back. And what you feel about the aircraft, what is happening to the aircraft or your body, you feel you are going up, then actually how much you are climbing, you feel even you are going more than that. This is a natural thing. Now, the similar feeling came to both the pilots because they were accelerating and they were climbing as well. Look at the time and what was ahead of time of this occurrence was around 7:30 in the night. Why I am calling night? Because sun had set around at about 6:30. So this was virtually 1 hour past the sunset. Moon was to rise at 12 o'clock midnight. So there was no moon in the sky. So it was a dark night. Next, Barren Island finishes here. All this is sea. So what is ahead of pilot? It's all sea. So it's a dark night. Into the sea, or at the sea, and you are getting this feeling that although you are climbing, you are climbing more than that. So what is a natural reaction? Put the stick down to overcome it. And this is what both the pilots did. They put the stick down. Why I said both the pilots? Because co-pilot concurred with their captain. Captain is putting the stick down, and aircraft started descending from 1,000 feet above sea. Whereas the feeling on the body of pilots was they are going straight. They didn't feel that they are going down because of that. And they continue putting the stick down. Virtually, this has got the fly-by-wire. So they put the full angle down. And now, there was another equipment on board known as GPWS, Ground Proximity Warning Light, warning system. GPWS is designed to give the proximity of the aircraft to the ground. So GPWS signal is very harsh signal. Woof, woof, bah! This is the mechanical voice. And as you heard this signal, it is even stronger than that. Now this type of signal came to both the pilots in the cockpit, on the audio. How many times? 12 times. again it was made to sound every second. So for 12 seconds they heard this, they did not react. What does it mean? Pull up means you are coming close to the ground. So pull up the aeroplane, pull the stick back. They didn't pull. Now why? So the analysis say that this was known as something as somatographic illusion. This is a proper scientific theory, what we discussed. When we are accelerating, we feel that as if we are flying. That is why teaching for pilots right from the first time somebody steps into the cockpit is trust your instruments. Don't trust your instincts. That is the teaching taught to the cadet who steps into the first time. And unfortunately, is the human tendency to rely upon their instincts rather than their instruments. So you are all familiar with the aircraft modeling, so you know the instruments, what they are in the aircraft. So although the horizon, natural horizon was not seen, we had the artificial horizon working on gyroscope. You could have relied upon that. So this is what happens. Now, coming back to the theory of James' reason, that humans are bound to make errors. So, to avoid the errors, what is to be done? Now, I'll go back one step and discuss that 360 degree before we go any further. Why did the pilot do 360? That was not a standard practice. Now, investigation found out that there was an operations order. They call it in their an operations circle. It is virtually an order. At any time, any pilot undertaking a go around, he has to file a report up and he will be questioned. Now, why this order came? We imagine the few years before year 2000. There was a fuel crunch, or the fuel prices were going skyrocketing. Therefore, the fuel conscious commercial guy was responsible for that order. Because each go around, fuel wise, would consume something like 800 liters of fuel. 800 liters in those days, something like a lakh of rupees. So one go around will cost the airline 1 lakh of rupees. If that is the case, he said at least let us give an order so that people are discouraged from doing go around. So when this point was discussed during the investigation in the first few days, Ponto, the airline came out with the words of that for the safety, any pilot going around will not be asked questions. That was the next one. Therefore, non-standard procedures should not be done, was another order. And similar situations were created onto the simulators and given as a training modules. So out of this accident investigation came that, and even today those training modules are followed. On the simulator trainings are given. I mentioned to you some of the errors done by the captain, some of the errors done by the co-pilot. Those errors are covered in that. And what is the duty of simulator? You can freeze the simulator in the air. Ask the pilot to redo that exercise. You can't do that on the aeroplane. You can do that on the simulator. You can repeat the exercise. You can take the aeroplane backward and take the pilot to ask the pilot to do the exercise again. So that is the advantage of simulator. So the training modules are prepared on that. And that is what James' reason proposed, that you do this. error management rather than error avoidance. Error avoidance may be difficult, but error management is simple. So the pilots, air traffic controllers, engineers are given this type of training so that they don't commit errors. More pieces of information, but I'll stop here because I extended my time, I suppose. I hope you found the explanation interesting. I had kept some time for question answers, but I don't think organizers will allow me for questions. Go over some of the questions posed to me quickly. Recovery and assembly of aircraft parts, how to analyze which parts failed. Now, again, a flight data recorder helps us in that. And flight data recorder will not only indicate each parameter of the aircraft, but when the parameter goes out of bounds or beyond certain limit, that indication will also be there. So from that, we can find out which part has failed. It is very important FDR data. Then, how does a pilot know if incorrect signals are being passed through the software? It's rather difficult, but training helps in that. Now, how training helps in that, I'll give a small example there. The accident occurred way back in early 80s in Bangalore. One 80s, I think, yes, 80s. One of the aircraft, again similar type, 320, was new in the Indian Airlines in those days, and that aircraft had an accident at Bangalore. What had happened was that aircraft had automatic signals wherein aircraft could go around automatically. Pilot has to just select one switch and the aircraft will automatically select the thrust to the toga, what I told you, take off, go around thrust, and automatically move the stick to an appropriate position to give proper climb angle. Now, this was selected inadvertently. And thereafter, pilots didn't know how to do the manual override, because that was an actual occurrence. And although the training was given, they were not familiar, they had not done that exercise. So subsequently, the training was changed, and in that exercise was done for every pilot in their 6-monthly training, that how inadvertent selection of that type of automatic go around can be manually overridden. Or similarly, anytime manual overrides are there, how they are to be operated, so additional training was given. So anytime new system coming in, this is likely to happen. Therefore, nowadays, more reliance on the automation. There is a lot of reservations on that. And we recently, when I say last 3 or 4 years time, some of the accidents indicate towards over-reliance on the automation. So, again, thinking has gone around in the industry that have less reliance on the automation, or wherever there is a larger number of automation, try and build in a system wherein training is given for the pilots to overcome that type of over-reliance on the automation. Ill health or incapacitation, how it is addressed. That is why we have 2 pilots on the aircraft. and the co-pilot is trained to do proper landing in case of such emergency. Otherwise, just to take back a step, that before a crew goes for a flight, the medical examination is done before every flight. So that even if somebody is on medication, that is in his report and doctor sees him. And not only that, the breath test is also taken for the alcohol. So this is done before every flight is in normal routine. So to avoid any incapacitation or any similar such things. But even if something goes wrong, in spite of that, then co-pilot is trained to do the landing. Bermuda Triangle. So, question from Mr. Khare. What my understanding about this is, it originally started with the ships. Ships felt that they were disorientated within that triangle, and whether the same thing was applicable to the aeroplane or not was a question. What happens is, ship speed is very low compared to the aircraft speed. So Bermuda Triangle, although it is there, geographically, if you see that, any aircraft crossing that triangle may not be more than a few minutes. Therefore, aeroplanes have never experienced that type of disorientation within the Bermuda Triangle. Not that I came to know any incident where aeroplane has reported that they have experienced any disorientation in the Bermuda Triangle. Have I answered your question? Now, the question about low-cost airline and their safety standards. Irrespective of what type of airline it is, their safety system has to be same like any other airline. Similarly, the regulator safety system has to be same like any other regulator. Therefore, the safety standards will not be compromised even if it is a low-cost airline. And airworthiness certificate can the passenger check on an aircraft? Okay, airworthiness certificate, generally what is done is, every aircraft is certified annually as far as airworthiness is concerned. So the airworthiness certificate is issued annually, and that certificate is kept on board aircraft. If you request the pilot, he'll certainly show you that certificate. It has about 2 pages certificate it is. It has various norms. Secondly, what happens, apart from that annual check, there are various checks on board aircraft, technical as well as operational. Those checks are carried out routinely, like a pre-flight check before flight, post-flight check, then some checks are periodic after so many hours. So the checks is a norm, and every check is recorded. There are recording books, and person who is doing that check has to write that book. Therefore, these checks are done regularly irrespective of that airworthiness. Now, all these checks contribute to that airworthiness. Feasibility of pilotless. Can such aircraft handle situation like a pilot? Very interesting question. In fact, let me quote you an example. F-16 American fighter aircraft, everybody knows in the sense because it was so much in the news. The F-16 has been successfully landed. Carried out full flight from on board carrier without pilot using this type of technique, and it's not too far when passenger aircraft will be flown like that. So it is very much a feasibility. And second is, you must have heard about artificial intelligence. Artificial intelligence is virtually acting like a human, and handling the situation like a pilot will not be a problem if you use the artificial intelligence properly. Although it is a theory at the moment, but when actually this type of situation occurs, we'll certainly come to know because it's a great news. Initial actions of the investigating team, I did cover that. Collect all the evidence within first 48 hours. Major reasons for air crashes. We did cover that actually. Major reasons for the air crashes are basically at the moment various factors, we call them. We don't call them errors anymore. Human factor is one of the major factors at the moment, and systemic factors are introduced. Going back to that Gulf Air accident, why pilot did 360-degree? Because the reasoning was put up that order was there, that if he goes around, he has to write a report. So he wanted to avoid that, so he went 360 degrees. He doesn't have to file a report. So he took the path of easy path. That became fatal. That is a different issue. But the thing is, systemic factors indicate that you must analyze why a human factor or error is occurred. As it may be somewhere in the system that may be responsible for that. That's all question I have. Anybody has questions, please. Yes.
Does the lightning affect?
Yes, it does. Lightning, what happens is, if you see the lightning theory, positive and negative charge. So you can just, everybody requires that. Positive and negative charge. Because let us say how lightning falls on a tree. Lightning gets attracted to the opposite charge. Same thing happens with the aircraft. So in the air, if air, normally in the clear air, there is no question of lightning. Where does the lightning occur? It is something known as cumulonimbus cloud. It's a rain cloud or a lemon. Rain cloud has the electrical charges, positive and negative both. So if the aeroplane goes through the rain cloud, then the chances of lightning striking aeroplane is there. And normally aeroplanes avoid cumulonimbus cloud. They don't enter the cloud, that type of cloud, because they know it is a dangerous cloud. Because not only lightning, it has got more danger, up and down drafts. Up and down drafts in cumulonimbus clouds sometimes as high as few thousand feet per second. Up and down. The aircraft is thrown up and down few thousand feet per second. You can imagine that is more dangerous than the lightning strike. But it has occurred, lightning strike. Any other questions?
Now it went inside the turbulence and people got.
Yeah, it's a spice jet, not jet airways. Yeah, that's what they say. The investigation is still going on. There are two types of turbulence we get. So one is known as clear air turbulence. There is no cloud. That generally occurs on the border of jet stream. You heard of jet stream? Jet stream is wind of very high velocity, something more than 100 miles per hour. Closer to that jet stream, the adjacent layers may not have that much speed. So aircraft is flying around that adjacent layer, it will get turbulence. So that is called clear air turbulence. So there is no cloud there. But in this particular case, that was not the case. That area is not of jet stream area. Jet stream area, the particular attitudes there. And secondly, the nor'westers were forecasted. Nor'wester is a type of storm. In Bengal, they call it nor'westers because it comes from northwest direction. And nor'westers will bring cumulonimbus clouds, and apparently they went through the cumulonimbus clouds. Now, why they went through that, I don't know. Generally, airplanes are equipped with radars, which allow them to avoid those clouds. Even if visually they can't see, radars can show them what is the dangerous part of it. So that is that turbulence type of. Okay, thank you very much.